Let's look at the Triangle-Angle-Bisector Theorem. It states, if a ray bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the other two sides of the triangle. So here's a picture of what's happening. AD is bisecting angle A, and then it's dividing this side, BC, into segments BD and DC, and those are proportional to the other two sides of the triangle. So let's try an example to kind of put it all together for us. All right, so here's my triangle. Angle A, again, is being bisected. So we're using the Triangle-Angle-Bisector Theorem to solve for x. So my instructions here are to solve for x. So since we learned from the theorem that the two segments at the bottom are proportional to the other two sides of the triangle, we can set up a proportion. When we set up our proportion, it will be the two sides of the triangle, x and 6. We write x over 6 equals the two segments of that bottom or that third side, 8 over 5. So I used the left values at the top and then these right values on the bottoms, the denominators of my ratios. All right, so to solve this, we simply cross multiply. X times 5, we just write as 5x equals 6 times 8 is 48. Divide both sides by 5. X equals 9.6. 248 divided by 5, you get 9.6. Let's try another one. All right, number 2. You can see my triangle labeled a little differently. So when we set up our proportion, using the same pattern as before, it should be 5 over x equals 4 over 3. That might really help you to draw in these arrows. 5 over x going from left to right, and then 4 over 3 going left to right at the bottom for that third side. Right, cross multiply. I'll start off with my x. X times 4 is 4x equals 5 times 3 is 15. Divide both sides by 4. X equals 3.75. Let's try a third example. All right, number 3. Side AB is 24, side AC is 40, and that third side, BD is x and DC is 30. So let's set up our proportion. So 24 over 40, starting with those two sides of the triangle, and then looking at that third side that's been divided into two pieces, x over 30. Cross multiply. 40x equals 24 times 30 which is 720. Divide both sides by 40. X equals 18. So using these arrows is what I found works the best for students to help them set up the ratios. So 24 over 40, draw in that arrow, equals x over 30, draw in that arrow. So remember which way to go. I will caution you, you need to make sure sometimes that triangle is flipped. Maybe it's upside down or maybe it's on its side. So it can be a little bit tricky knowing how to set up that ratio. All right, let's try number 4 where the algebra is a little bit harder. All right, number 4. Side AB is x plus 4. Side AC is 2x. And then that third side, we have the segments 9 and 12. So, again, don't be afraid to draw on those arrows. That will really help us set up the proportion correctly. X plus 4 is where we'll start, over 2x equals, same thing, start with a 9 and go to the right, 9 over 12. And that's how you set up your proportion. We cross multiply. 9 times 2x is 18x equals, be careful here. So we have the number 12 times x plus 4. That is the quantity x plus 4, so it needs to go in parentheses. Our next step will be to distribute the 12. When we distribute, we use multiplication. So 12 times x plus 12 times 4. So bring down your 18x on the left side, your equal sign. 12 times x is simply 12x plus 12 times 4 is 48. We have x's on both sides. So let's move one of them over. I'm going to move the 12x over. We do that by subtraction since it's positive 12x. Subtract 12x from both sides. Gives me 6x equals 48. Divide both sides by 6. And my final answer, x equals 48 divided by 6 is 8. All right, let's do one more example. All right, so I flipped the triangle a little bit just to help us get used to doing problems where the triangle might not be how we're used to seeing it. So still starting with those two sides of the triangle, we're going to go 8 over 5 equals, in that second ratio, let's use that third side that's been divided into the two segments and go in the same direction as you went for the other two sides. So here, bottom to top, x over 3. Cross multiply. I always start with the two that involve an x. 5 times x is 5x equals 8 times 3 is 24. Divide both sides by 5. X equals 4.8. So that is how you use the triangle-angular bisector theorem to solve for a missing number.